All right, so I finished my general announcements. That included reminding students that they can retake CFU number 3 by next week, Tuesday, and then we have a test coming up this week on Friday. Students have received a yellow review packet. That review packet is due the day of the test and can count as 10 points towards the test. It's also graded for completion, not accuracy, because students will be given class time tomorrow to work on it, and Mr. Fee and myself will be very forthcoming in helping students with that. So we're not grading it for accuracy, we're grading it for did you try it. And the promise that I made is that if you can do the notes today and you can do the review packet tomorrow, you can do anything that I'm going to ask you to do on the test on Friday. Okay? All right. I already gave you all time to complete the multiplication at the top of page 41, so I'm going to get right down to the bottom. Believe it or not, this is the very, very, very first thing that we did in this class, all the way back in August. Okay? Granted, we probably didn't do an equation this complicated looking. We did simpler equations when we first did it. Number 1 says create an accurate graph of the equation f of x is equal to the parenthesis x minus 2 close parenthesis squared minus 1. Plot label at least 5 points on the graph. Use interval notation to express the domain and range. Okay, remembering the domain is how far to the left does the function go, how far to the right does it go, range is up, down. Okay, so what's the first thing I always recommend that you all do with your calculators? Reset them, exactly, because you have no idea what somebody else did with it. Remember, you reset it by hitting second plus 7, 1, 2. Now, from here, I'm going to go to y equals, and now I'm fully confident I don't need to worry about what somebody else did with this thing. And I'm going to type in this equation exactly as it appears. Parenthesis x minus 2, close parenthesis, squared minus 1. So parenthesis x minus 2, close parenthesis, squared minus 1. Now, our goal is to create a sketch of the graph, and to do that, we want to get some points. What I've recommended in the past is you first hit the graph button. Look at the thing that you're trying to create. Okay, and this will give you some idea of what points you want to get. For example, I notice this parabola bottoms out at an x value of 2. So that's a really important point to get on the table. When I go to the table, I definitely want to get the point when x value is equal to 2. Now, it's probably a good thing to get the points around it. So to get to the table, you hit second graph. And as I said, I definitely want to get this point. I definitely want to get the point 2, -1. Okay, but then the other points around it are good points to get. I quite frankly don't care what points you get, but remember, don't take points that have values that are off the graph. Okay, so the 15, way too big. That's not going to help me. And if I want to go back, I can take 0 or -1, but I can't take -2 because it's off the graph. Now, the points I decided to take were these. Not that you would have to take those exact 5 points. You have your choice of which points you want. But when I create that graph, it ends up looking like this, which is exactly what it looked like on the calculator. Now, this was actually the limits of CFU number 1. When I gave you all CFU number 1, this was the only thing I asked you to be able to do. Plug an equation into a calculator, get some points, create the graph. And there were 2 problems like that on CFU number 1. CFU number 2 added on this domain and range thing. Now, here's what I'd like you to notice. This function doesn't end at the top of the graph. It just keeps going and going and going and going. It goes up forever. So I know for a fact that the range is going to involve positive infinity, because this thing just goes up forever. But notice that as it goes up forever, it's going to the left forever, and it's also going forever. So the domain is going to be -infinity to positive infinity. The range I haven't quite finished with yet. I've already mentioned that it goes up forever, but notice that it bottoms out right here at -1. It never goes lower than -1. And it actually touches at -1. I mean, that's a solid point at -1. So I'm going to make sure that I put a bracket around -1, because that's as low as it goes. Now, I understand on CFU number 2, a lot of people struggled with, do I use a bracket? Do I use a parenthesis? That is actually why I specifically created a couple other problems that we're going to look at. So later today, problem number 3, we're going to look at a few more domain and range examples. And I created those specifically so that we can have more practice with when should we use a bracket, when should we use a parenthesis. So for now, I'm going to keep that explanation really simple, and I'm just going to say this. This function actually touches -1. That's why I used a bracket. But infinity is not a number you can touch. It keeps going and going and going and going. And if you stop because you think you touched infinity, you're wrong because it keeps going. You cannot touch infinity. That's why we always use a parenthesis with infinity. It's not a number you can actually touch. Okay? Questions? All right. So that's the first thing. Can you type an equation into your calculator? Can you create points and a graph? And like I said, we'll get even more practice with domain and range here in a moment. Okay. Now, the next thing you have to be able to do is calculate an inverse function. That's what number 2 is going to start with. It's going to say, given f of x is equal to 3x minus 2, find the inverse function. Now, we learned 2 different methods for finding an inverse. If I give you a list of steps, like add 5, take the square root, subtract 8, if I give you a list of steps, well, then the way you create the inverse is you take those steps and you flip them and you reverse them. Okay? So instead of subtracting 8 last, you would add 8 first. That's one way. The other way is a 4-step process where we actually calculate the inverse function. Okay, not that you have to label it, that's why all of that is in green. Does anyone recall, if I want to take f of x equals 3x minus 2 and turn it into the inverse, what's step number 1? Remember, I warned that step number 3 is the hard one. Yep. All right, I heard change the x to y. Is that what you said? That's actually going to be step 2. He's 1 step ahead of me. I don't see a y anywhere. That's kind of step 1. What do I have to do with the f of x? You can look back at your notes if you need it. Step 1 is supposed to be, say again? Well, we're trying to calculate the inverse, and then I heard somebody say, you switch it to y. You got it. So step 1 is you change f of x to y. That's step 1. You need a y. I heard in the beginning somebody said switch the x and the y. I think that was even. Okay. But we can't switch with x with y unless we have a y first. Okay. Now we can switch the x with the y. So notice those first 2 steps, they're really meant to be kind of simple. Okay. Not really calculation based. It's just procedural based. Change f of x to y and then switch the x and y. Now, step 3 is, again, in my opinion, the hard part. Step 3 is where you have to solve for y. You have to get y by itself. So what should I do first? I heard divide, but remember, addition and subtraction comes before division and multiplication when you're solving. Perfect. We're going to add 2 to both sides. That turns it into x plus 2 equals 3y. Now, how do we get y by itself if it's currently being multiplied by 3? You divide. Exactly. So you divide both sides by 3. That's the end of step 3. Step 3 is get y by itself. So the moment y is by itself, you're done. Now, step 4, I'm basically going to copy what we already have written, the x plus 2 divided by 3, okay? But there's one other thing that I need to do, okay? You good? All right, make sure you're taking notes for me, sir. So I'm going to switch y to f inverse of x, and now I'm done, okay? All right, so this is one of the other skills you need. If you are given a function, you need to be able to calculate the inverse. Now, the next part is kind of a repeat of what we saw on the previous page. Part B says list at least 5 points on f of x. Remember, f of x is 3x minus 2. So to do this, you would go to the calculator. I would recommend, since it's a new problem, second plus 712, go ahead and reset the calculator. And then I'm going to type 3x minus 2 into y equals 3x minus 2. Now, again, I recommend hitting graph. That way you can get a sense of what you're trying to create. But here, because it's just a straight line, it really doesn't matter what points you take, because you're just going to get a bunch of points that are going to fit a line. So when you go to the table, I just want to continue to stress, don't take points that are too big. Okay, don't take that 5, 13. And if you go the other way, don't take, well, 3, negative 11 isn't too bad. It's only 1 box off the grid, but certainly don't take negative 4, negative 14. Okay, but any of the points in between, you decide. Now, when I did this, okay, and then I saw a hand, I'll get to you in just a moment. These are the points I decided to copy. Okay, so go ahead and write those down, but keep in mind on a test, these are not the required points. You can pick whichever points you want. Okay. Now, Part B, I've only done half of it. It says list at least 5 points on f of x. I did that, as well as the corresponding pairs on f inverse. So can anyone remind me, how do we take these points and turn them into the inverse points? What should you do with those numbers, folks? You switch them. You got it. Thank you, ma'am. All right, so do exactly what Tao just said. Take your, originally I have 0, 1, 2, 3, 4 in the x position. Switch that to the f inverse position. Originally, we had -2, 1, 4, 7, 10 in the f of x position. Switch that to the x position. Right? That is how you create the inverse. You literally just take the points and flip them. Okay? Now, the next part of this is, again, just kind of a repeat of what we did on the previous page. The very first problem that we did today was get some points, create the graph. Okay, well, here, this page started with, can you calculate the inverse? And then it's, well, can you create the table for the inverse? And now it's going to be, can you create the graph of the inverse? Okay, now I'm hoping we're at a point where if I gave you all time, you could take these points 0, -2, 1, 1, 2, 4, 3, 7, and you'd graph them. Okay, and you'd get this. Okay, the points should be in a line. Now, before we even get to the inverse graph, I want to stress something real quick. Remember that I said before, anytime you take a graph and turn it into its inverse, what you're going to be doing is reflecting it across this line. So what I would argue is you could actually picture what the new line is going to look like before you even graph it. Okay, watch. This portion of the line is going to reflect to look kind of like that. Everybody see that? Reflects across that green line. And then this portion of the line is going to reflect across and look something like this. So before you even create the inverse function, it would hopefully make sense to us that the function is going to look something like that orange and purple line. And indeed, that's exactly what happens. If you take those inverse points, -2, 0, 1, 4, 2, 7, 3, and you graph them, you get this. Which wasn't perfect because I was drawing it by hand, but that does a pretty good job of lining up with what I said we should be expecting. Okay? Wasn't perfect because I drew it by hand, but pretty much exactly what we should have expected if we picture what an inverse function does. Okay? So to sum up this page, it's, can you calculate an inverse? Can you create a table of values for an inverse? And can you graph an inverse? I'm going to pause to give people a chance to catch up because, like I said, I know I'm moving fast today, but then we're going to turn the page. All right, go ahead and turn the page. Let me summarize what's going to happen on this one. The top is going to be practicing just naming the domain and range, and I'm hoping that I can put more focus on clarifying for you all when to use a bracket, when to use a parenthesis. Okay, the bottom of the page is going to bring even more just mathematical operations and inverse function type stuff into the picture. Okay. All right. So number 3 says use interval notation to express the domain and range of each function's graph. Okay, so I'm going to start with the graph on the left. Remember, the domain is left, right, range is up, down. So I don't recommend you all scratch all over your paper like this, but I just want to show you where my head goes when I'm thinking about domain. I look at the leftmost point and I remind myself, okay, it doesn't go any further left than that. So it doesn't go any further left than -5. And I find the rightmost point, and I say, all right, it doesn't go any further to the right than that. This is basically how you can figure out domain. What is the furthest left? What is the furthest right? So it goes as far to the left as -5. It goes as far to the right as +2. But then you also have to pay attention to, should you use a bracket or a parenthesis? The point up here, which reaches to an x value of -5, is a closed point. It's filled in, which means the graph actually touches at that location. But the hollow point over here at an x value of 2 tells you it doesn't actually touch that point. It just gets really, really close to it. Okay? So you should be using a bracket around the -5, but a parenthesis around the +2. That's your way of communicating to me. We actually touch at -5, but we don't actually touch at +2. Okay? Now I'm going to erase all those crazy red markings, and I'm going to switch my thought process to the range now, which is the up-down motion. Okay? So if I'm analyzing this picture up-down, the farthest down it goes is -7. It doesn't go anywhere lower than that. And it actually touches at -7. There's not like a hollow point there. It actually touches at -7. So I'm going to use a bracket around -7. But then in terms of going up, it reaches as high up as this point, which is at a y value of +9. And it's a closed point, so it actually touches at +9. So believe it or not, both values are going to get a bracket there. Okay, and on your test on Friday, there's definitely going to be a problem where you have to talk about domain and range, and part of the points is going to be, did you use a bracket when you should have used a bracket? Did you use parenthesis when you should have used a parenthesis? Okay. Questions? For the next picture, the first thing that occurs to me, or the first thing I notice, is that this part of the graph just shoots down and to the right forever. Okay. So remember, domain is left and right, and I now know that this thing goes to the right forever. So I know the domain is going to end with positive infinity, and range is up down, and down forever. So I know the range is going to reach to negative infinity. But I haven't even gotten to the other numbers. Just noticing that this function goes down and to the right forever tells me those two parts. Okay. But then looking at the hollow point, this thing goes as far to the left as -6 and as far up as +5. Okay. So our range, or excuse me, our domain, it goes as far to the left as -6, but it's an open point, so it doesn't actually touch -6. And then our range, I know it looks like it went a little bit above 5. I'm not going to try to trick you like that on the test, so I'm just going to treat that like it touches 5. Okay, but it actually touches 5. It's not an open point up there. It comes up, hits 5, and comes back down. So that's the top of the range. Okay? Questions? So I never know if I should be concerned when there are no questions. I think I've only been asked 2 questions today. And when I'm not being asked questions, to me, I don't know if I should be happy or worried, because it either means nobody has any questions because you understand, or nobody is bothering to ask a question despite the fact that you're confused. Yes, sir. Good deal. All right, moving down to number 4. We only got 3 problems left. Okay, so this is going to on your ability to use functions and discuss inverses. And my hope is that when we're done with this problem, you can kind of appreciate the flow of this problem as well as the flow of the next problem, because they're very related. You'll see what I mean. Number 4 says, using f of x equals 3x minus 7, find f of 4. So it literally just means plug 4 into that function. What's 3 times 4? 12. What's 12 minus 7? I heard 3, but that's too low. 5. 12 minus 7 is 5. Okay? So the function turned 4 into 5. We plugged in 4, we got 5. Now, part B says substitute the value you found in part A. So take that 5 and substitute into this function. You don't have to write that notation if you don't want to. That's why I put it in green. But what that communicates to a mathematician is using a function labeled g, and you're plugging 5 in for the variable. So g of 5 would look like this. 5 plus 7 divided by 3. Now, 5 plus 7 is 12, divided by 3 is 4. So what I'm hoping you would, part C says, what do you notice? What does this mean about the functions f of x and g of x? What I'm hoping you would notice is that we plugged 4 into f of x and got 5, and then we plugged 5 into g of x and got 4. So what I'm hoping you would notice is that we started and ended with the same number. We started with 4, we ended with 4. And what does that mean, by the way, if f of x turns 4 into 5 and g of x turns 5 back into 4, what does that mean about f of x and g of x? What kind of functions are they? That was a question for you all to answer. What kind of functions are f of x and g of x if they do the opposite thing? I'm not moving from that without you all, because that's what we've been talking about for the last week and a half. If you have a function that turns 4 into 5, and then another function that turns 5 back into 4, yes, sir? I put 4 up there in the original x. Yeah, that was part A. So I heard Ibuka say it. I think that was you. Inverse is correct, but to respond to Emerson's question, I want to make sure I'm being clear. We took 4, plugged it into f of x, and got 5. Then we plugged 5 into g of x, and it got us back to 4. Does that make sense? Okay, and what that means is that f of x and g of x are inverse functions. That was the word I was hoping somebody would give me, inverse. You have two functions that do the opposite thing. That's what inverse functions do. All right, go ahead and turn the page. As I warned you ahead of time, number 4 and number 5 are really, really similar. They're really related. So if you can understand the flow of number 4, I'm guessing that number 5 is going to make a lot more sense. Yes, sir. Now. All right, so top page 5, or excuse me, problem number 5 at the top page 44 says using p of x equals x squared minus 9, find p of 5. So we plug 5 into the equation. What is 5 squared? 25. What is 25 minus 9? What is it? 16. You got it. By the way, the way I teach my own kids to subtract 9 is I just say, pretend like you're subtracting 10, because that's a lot easier, and then just add 1 back in. So 5 squared is 25. If you subtract 10, it drops to 15, but then add 1 back in because you were really only trying to subtract 9, and you get 16. Now, part B says substitute the value you found into the function r of x. So we're going to plug 16 into r of x. Now, this says take the square root of 16 and then add 9. The square root of 16 is... What number multiplies by itself to get 16, folks? I'm waiting for the whole room. I'm not moving. There you go. 4. 4 times 4 is 16. Square root of 16 is 4, and 4 plus 9 is 13. Now, the next question, just like on the previous page, says, what do you notice? What does this mean about the functions? What I'm hoping you'll notice is that we plugged 5 into this equation, and it got us 16. But then when we plug 16 into the new equation, it does not get us back to 5. So one function turned 5 into 16. The other function turned 16 into not 5, something else. So we started and ended with different. What does that mean about p of x and r of x? What are they not? It's the same thing we saw on the previous page, folks. They're not inverse functions. You got it. This means that p of x and r of x are not inverse functions. Okay. Number 6 says, given x squared minus 2, find at least 5 points on the graph of the function, then plot at least 5 points on the coordinate grid to the right. Once again, I'm going to do this, in my opinion, way too fast for you all to keep up, so just kind of watch, okay? I'm going to reset my calculator. I'm going to go to y equals and type x squared minus 2. I like to look at the graph to get a sense of what the picture looks like. I notice that it drops down here. Its very bottom point occurs at 0, negative 2. So that is a point I want to make sure I get. 0, negative 2. But in terms of the other points, you can get any of the points that don't go beyond 10. So don't get negative 414. Don't get positive 414. Get any of the other points. Okay? You can decide which ones you want to get. Now, I went with the blue ones, but I listed a few extra just in case those are points people went with. As I said, you could take points anywhere from negative 4 to positive 4. Okay? And if you graph it, you get these points. I graphed my green ones in green just so you could see the ones that I chose to use, but how you could use more if you wanted to. And part B says, use the points from part A to create 5 points that are on the inverse function and plot those points on the grid to the right. So again, all I'm going to do is take my negative 3, negative 2, negative 1, 0, 1, 2 x values and put those in for my f of x. Negative 3, negative 2, negative 1, 0, so on. I'm going to take the 7, 2, negative 1, negative 2 and put those in for my x values. And then when you plot those, you get the same parabola, but it's been flipped across that diagonal line. So now instead of pointing up, let's just be clear, the original function looked like this, but when you flip it across this line, it ends up looking like that. Hopefully you can kind of see what I try to draw by hand. All right. And with that, we're done. So we still have about 7 minutes. I know I, again, went through that really, really quickly. Okay. I'll try to leave both on the screen there. There we go. Okay. But tomorrow in class, we're going to donate the entire period to you all to be able to work on your yellow review packet. That's going to be collected on Friday. It'll count as 10 points on the test. Remember, the test this Friday is not retakeable. It's a one-shot deal. Okay? Those watching, thanks for watching. Have a good one.